You've seen this happen, right? You ask an AI a pretty simple question, and it gives you this completely made up answer, but it says it with so much confidence. It's called a hallucination, and it's one of the biggest headaches in AI today. But here's the crazy part. What if these models aren't actually broken? What if we're the ones teaching them to lie? Okay, let's get into it. Yeah, this quote right here, it's basically the key to this whole thing. It completely flips how you should think about the problem. See, the AI isn't some rogue machine making stuff up for kicks. It's a student playing a game that we designed. And as it turns out, the rules of that game are seriously flawed. So, if the AI is just a student taking our test, how did we end up accidentally teaching it to lie? Well, it turns out this whole making stuff up thing isn't some random bug. Nope, it's actually a predictable feature, a direct result of the exact methods we use to build and grade them. To really get this, we've got to go back to basics. How do these models even learn in the first place? Because, it's not really about understanding in the human sense. It's more like a massive high stakes guessing game. So, at its core, what is a large language model? Well, think of it as this unbelievably powerful prediction engine. It's read a giant chunk of the internet, and its entire job, its only job, is to look at a string of words and guess what the next word is most likely to be. It's basically a statistical guessing game, just on a scale that's almost impossible to imagine. And this is where the first crack starts to show. This number, 20%. Research shows that about 20% of all the facts in a typical training dataset show up only one time. So imagine some obscure fact, like a specific name or a date, buried deep in some old document. For a model that learns by seeing patterns over and over, a fact it's only seen once, well, that's just statistical noise. It has no reliable way to pull that back up. And boom, that's where the problem really starts. When you ask the model about one of those rare facts, it can't find a high probability answer in its data. But it doesn't just stop. It does the next best thing. It constructs a sentence that looks right. It fills in the blanks with words that are statistically plausible. So you see, a hallucination isn't the AI going crazy. It's just a statistical error that's really, really good at dressing up like a real fact. Okay, so the training data gives the AI a blind spot, but it's how we test them that turns that little blind spot into a full-blown habit of just making stuff up. Because in the AI's exam, bluffing is a better strategy than being honest. So after all that training, we have to grade them, right? We use these things called benchmarks. And honestly, they work a lot like a multiple choice test you'd take in school. The kind where there's no penalty for guessing. Let's break down the scoring system, because it's super simple. You get an answer right, plus 1 point. Awesome. You get it wrong, you get 0 points. But here's the kicker. If the AI is honest and says, I don't know, it also gets 0 points. You see the problem here? A wrong answer and an honest I don't know are worth exactly the same, nothing. So, let's put you in the AI shoes. You're taking this test. There's 0 penalty for getting something wrong. What do you do on a question you're not sure about? Are you going to leave it blank? No way. Of course not. You're going to guess every single time. Why wouldn't you? There's no downside, and you might get lucky. We've literally designed a system where bluffing is the best possible strategy. We have accidentally, but very effectively, taught the AI that it's better to give a confident, wrong answer than to just be honest and say, I don't know. Okay, so if the problem is really just a messed up incentive system, how do we fix it? Well, the solution isn't some crazy, complicated bit of engineering. It's actually shockingly simple. All we have to do is change the grading. And this clever solution actually has a name. It's called confidence-aware evaluation. It's really all about creating a new set of rules that forces the AI to think before it speaks. A system where finally, honesty pays off. And the whole fix? It's right here. Look at this table. The top row, that's the old way. The bottom row? That's the new system. A right answer is still +1. I don't know is still 0. It's neutral. But look at what happens when you get it wrong. -2 points. That changes everything. Now, all of a sudden, bluffing is a terrible idea. That -2 is a huge risk, and it far outweighs the small chance of a lucky guess. So what's the best strategy now? It's simple. Only answer if you're actually confident you're right. Otherwise, the smartest move is to just say, I don't know. Now, I know this might seem like a tiny little tweak to a grading system for a computer, but this is so much bigger than that. This simple change has huge implications for the one thing we really, really need from AI: trust. Think about it. Every single time an AI just confidently makes something up, our trust in these systems goes down a little bit. We don't need them to be know-it-alls. What we actually want are tools that are reliable, tools that know what they don't know. And this whole thing proves that the answer isn't always just make the model bigger. Sometimes it's about making the rules smarter. So, here's the bottom line, the big takeaway. These AI hallucinations, they aren't some spooky ghost in the machine that we just have to live with. Not at all. They are a direct result of the rules we created. You fix the grading system, you fix the behavior. It's that simple. And that leaves us with a really fascinating question to chew on. If fixing something as huge as hallucinations is really this simple, just changing the incentives, what other big problems in AI are we trying to solve with ridiculously complex code when maybe all we need to do is create better rules for the game?